refrigerant charge and airflow is a really important part of making air conditioners efficient. And that's why the 2008 standards have some significant changes over the 2005 standards. And with me today is Mazi Shirakh from the Energy Commission. So let's go back to the 2005 standards, because that sort of set the stage for why the 2008 standards are different. So we just kind of talk about that, particularly with regards to refrigerant charge and this airflow verification.
Yes, Steve. The 2005 standards required refrigerant charge verification, but those standards also provided a very easy alternative to refrigerant charge verification, and that was installation of a thermostatic expansion valve, or the TXV. And what we learned is that almost everybody, all the installers out there, they chose the TXV option and not the refrigerant charge verification.
And what was the impact of that?
The problem with that is we found out that through research that the TXV does not give you the same level of efficiency as proper refrigerant charge and verification.
And it tries to modulate as opposed to just a standard orifice, but it just can't possibly keep up with making sure that you get that refrigerant charge.
Exactly.
Which is critical to efficiency.
You know, if the system doesn't have the proper charge, TXV cannot completely compensate for that, and the efficiency of the system will drop, the capacity will drop, the system will have to work harder, there's going to be impact on energy, on peak demand.
And capacity too.
And capacity, so you know, a 4-ton system will not operate at 4 ton, it will be at something less, maybe 3 ton or lower. So in the 2008 standards, we eliminated the TXV alternative. And the result of that is will be that more people, more installers will actually have to do refrigerant charge verifications, and all of these will have to be verified by a HERS rater.
Yeah, now there's a couple different methods in which we can verify refrigerant charge, and one of the concerns is that when you hook up gauges and so forth, that some of that refrigerant can be released in the atmosphere, which is not a good thing. So you guys have developed and devised some different scenarios by which we can actually check refrigerant charge through temperature sensors.
Yes, the concern is, as you mentioned, is that when you put pressure gauges on the refrigerant line, some refrigerant can escape, and some people were not happy about that prospect. So we provided in the standard alternative to pressure gauges by providing temperature sensor measurement ports, and also access holes for measuring temperatures and static pressure in the duct system.
So basically, these temperature measurement access holes are put in the return air plenum and also in the supply plenum.
Supply air plenum, correct.
And they help us measure temperature, correct?
Correct. They help you measure temperature, and then the saturation temperature measurement sensors allow you to measure the saturation temperature, and with that information, people can verify the correct refrigerant charge.
Yeah, I suppose if you know the temperature difference across the coil and so forth, it helps us understand when that saturation takes place. But the whole concept is to get efficient use out a transfer of heat from the heated air in the home that needs to be cooled, right? And that's these probes help us determine
They
that.
will do that. Basically, they help the installers and the raters to make sure that the system is properly charged and therefore is operating much more efficiently than with just a TXV system that has improper charge.
And we can also use a charge indicating display as another method to help us determine refrigerant charge, correct? Can you tell me how that works?
That's correct. The standards provide an alternative to refrigerant charge verification and the temperature sensors and the access holes. And that alternative is called the charge indicator display. And this is a device that's installed. It will alert the occupants if the airflow is incorrect or the refrigerant charge incorrect. There will be a display installed next to the thermostat, and that display will alert the occupant that something is wrong, the system is not working right, and that will prompt the owner to call in the technician to come in and take corrective action.
That's sort of an early warning device. And the concept, I guess, if you don't have adequate airflow across the coil, it's not going to cool well. So the airflow is very important as well.
The adequate airflow is very important to provide the capacity that you need and the comfort. And inadequate airflow could also result in icing on the evaporative coil. So that's not something that you want to have, and obviously improper charge will have negative impacts too.
As a result of 2008 standards, there's also some requirements around airflow and fan wattage draw?
Yes, Steve. In 2008 standards for new space conditioning systems, there's prescriptive requirements for fan watt draw and cooling coil airflow requirements. For cooling coil airflow requirements, they must meet 350 CFM per nominal ton or greater, and fan watt draw of 0.58 watts per CFM. Both of these requirements must be met simultaneously.
So why is that, Mazi?
By meeting both of those requirements at the same time, it ensures that your system is at its peak efficiency and it delivers the cooling required in the most efficient manner.
And what about watt draw?
Same thing, because watt draw is a calculation of 0.5 of watts per CFM. So the lower that number it is, it means the less energy is using for delivering the same amount of CFM.
Okay. Let's talk about replacement of systems. There are certain new requirements with regards to systems if I'm replacing the entire system or if I'm replacing just some of the components. Can we talk about the new standards requirements for that?
Yes, if you're replacing an entire system or you're putting in an entire new system in an existing home, the requirement for those are pretty much the same as a newly constructed building. That is, you have to meet the duct sealing requirements that are less than 6%. You have to meet the cooling coil airflow that are better than 350 CFM per nominal ton. You have to meet the fan watt draw that are 0.58 CFM or less. So it's essentially like putting in a new system in a new building. Now, if you're replacing only or altering components of an existing system,
Like just replacing, let's say, your coil or your
outdoor unit or your coil or the components of the duct, then the requirements are different. And there's really a lot of different variations on what the requirements are. And we have developed a question and answer in the Residential Compliance Manual. That's example 8-28. And it goes through 9 different scenarios for alterations to an existing system and with the corresponding answers. So, you should consult that document and look at that example for your specific requirement and see which one is closest to your project, and the answer is given there too.
So, Mazi, in summary, the 2008 standards look like they're going to save some energy.
You're correct, Steve. The intent of the 2008 standards is to finally get the air conditioning right, to work the way it's supposed to be. And the refrigerant charge verification and the fan watt draw will go a long way towards delivering the comfort that the occupant wants, and also saving both energy and peak demand on the hottest day when the state will be struggling with delivering enough electricity throughout the grid. So the 2008 standards really tries to do something about that, and it's very important that all of these measures are implemented and verified by third-party HERS raters.
Well, Mazi, thanks for sharing that information.
Thank you, Steve.